Hello, and thanks for checking out Chemistry Connections on the Hopewell Valley Student Podcasting Network, a proud partner of hvspn.com, where students come together to publish content to share with the world. The opinions represented within this episode are those of the content creators only. Please enjoy the show.
Welcome to Chemistry Connections. My name is Christian Mayer.
And my name is AJ Yadamiec.
And we are your hosts for episode number 7, called the 19th Hole. Today, we will be discussing the chemistry of golf.
For those who are not familiar with golf, the objective of the game is to get a little ball into a hole far away by hitting it with your clubs in as few shots as possible.
A typical round of golf consists of 18 holes. Each hole has a par, or number of strokes typically taken to get it into the hole.
The par for an average round of golf is 72, but it can be 71 or 70 depending on the course.
And a golfer carries around with them a bag of clubs, each with a different purpose and distance capable of hitting the ball.
On the tee box, which is where the hole starts, golfers will typically use a driver or a wood in order to get maximum distance on their first shot.
From there, depending on the distance of the hole, the golfer will hit an iron or wedge to try and get on the green, which is the shortly cut area of grass on which the hole lies.
Once on the green, the golfer will use their putter, an unlofted and usually shorter club, to try and putt the ball into the hole.
Each club is made up of 2 parts, the shaft and the club head.
A different material is used for the heads between the 3 types of clubs, with lightness being preferred for the driver in order to achieve a high swing speed. Strength is favored in iron materials to add power to the shot, while a heavier material is preferred for the putter for greater control.
We are interested in this topic because we both love to golf. I've been on the golf team for 4 years in high school. I'm a 10 handicap, which means on a par 72 golf course, I would shoot around an 82 or 10 strokes over par. My favorite club I have right now is my 3-wood, which has a graphite shaft and a stainless steel club face, with 17-4 stainless steel club head.
I mainly just play for fun. I got into golfing a year ago, but I am not that good. I enjoy golfing very much. I like to play scramble, which is when you play with a partner, and we usually shoot around 100 on a par 72 golf course, which is pretty poor. My favorite golf club is also the 3-wood.
Now that we've gotten a basic understanding of golf, we're going to play a theoretical hole with you. While we play, we will dive into the chemistry behind the sport. So you take out your golf ball. Let's say the top of the line Titleist ball, the Pro V1.
What seems like a very simple dimpled white object at first glance has been engineered meticulously to allow for the perfect amount of distance, control, and spin on every shot. Golf balls consist of 3 main layers: the core, the mantle, and the cover. Golf ball manufacturers change these 3 parts to increase distance, increase control, and increase feel. This often is referred to in golf as initial velocity, spin rate, and compression. The core is where the energy is stored that will be released on impact of the golf club. Synthetic rubbers infused with polymers are the modern material for cores of golf balls. These cores are made up of long carbon chains that can be compressed and released, which stores energy and releases energy.
The mantle of the golf balls are made of ionomers. Ionomers are similar to polymers in that they are long chains of molecules covalently bonded together. However, ionomers contain both neutral and ionized molecules in its chain, though no more than 15% of the units in the ionomer chain are ionized. Ionomers have viscous properties because the nonpolar pieces of the polymer chain are not energetically compatible with the polar ionic groups, and are used for the mantle to reduce some of the spin generated by the core during impact with the club, which overall just increases the ball or the distance that the ball travels.
The covers of golf balls are the hardest working part of the ball. They must be as stiff as possible to use the energy the most efficient way and fly across those long distances. The covers cannot be too stiff, however, or they will crack easily. To meet this criteria, Some golf ball covers are made of urethane. Urethane, or C3H7NO2, is a carbon chain with an OH end and an NO2 end. These polar ends form very strong intermolecular forces which help urethane fit the criteria of the golf ball cover. The intermolecular forces include hydrogen bonds, one between the OH end and the oxygen atom at a different point in the chain, and another hydrogen bond between the NH2 end and the oxygen atom at a different point.
Now you tee up your shot and take in the landscape of the first hole. It's a 410-yard par 4 with a nice wide fairway. AJ, what do you recommend I hit on this shot?
I would recommend a driver here.
Sounds like a plan. Most common driver materials are made out of titanium, a development that started in the 1990s. The properties behind titanium make it both a strong yet lightweight material that allows for fast swings and consistent contact. Titanium alloys such as 6,4 titanium or beta titanium are extremely common as well. Pure or high-grade titanium is used typically only for the face of the club, while the head of the driver is a different, cheaper, and lighter material.
What makes golf companies choose titanium for the club heads or faces in drivers?
So titanium is an extremely strong metal with a low density, and its strength can be attributed to the fact that a titanium ion has 4 delocalized electrons during metallic bonding, which creates a larger sea of free-flowing electrons between the titanium ions, thus strengthening the attraction between the titanium ions. You hit it dead center of the face and land your shot in the middle of the fairway. A solid 250-yard drive.
I'd say that titanium club face sure is doing a good job.
Those ions sure are putting in the work. We've got about 160 yards to the hole. What would you hit here, AJ?
A soft 7-iron for sure.
Despite their name, irons are not solely made from iron and are made instead from stainless steel, typically the alloys 17-4 or 431. 17-4 stainless steel is named as such because it is approximately 17% chromium and 4% nickel. This alloy is both interstitial and substitutional since both chromium and nickel are similar in size to iron, but other elements like carbon differ greatly in size from iron. The content of chromium in the alloy allows for very good corrosion resistance since the chromium forms a thin layer of chromium oxide, protecting the iron from forming Fe2O3, or rust. This allows the clubs to be played in harsher weather conditions. What a shot! You sure this is your first time? Looks like a 10-foot putt for birdie, which is 1 under par. AJ, what's up with putters?
Well, there are 3 main materials that putter heads are made of: brass, carbon steel, and stainless steel. Brass putters are not seen often anymore because of how malleable brass is. Brass is an alloy made of usually 1/3 zinc to 2/3 copper ratio. This alloy is structured in a metallic lattice, which means tightly packed metal ions arranged in clumps. This alloy is also substitutional because zinc atoms are a similar size to copper atoms. The two are next to each other on the periodic table, meaning their valence electrons exist in the same sublevel. You would expect copper to be a larger atom than zinc based on general periodic table trends, but these trends can differ. One example is with zinc and copper. If you imagine a graph of the atomic radii of transition metals, you would expect a negative slope the whole way from left to right, but the curve actually kicks up at the end and the radii increase because when you pack so many electrons into one d orbital, they begin to repel each other and spread out. This means that zinc atoms actually have a larger atomic radius than copper atoms, but they are still very similar in size. The substitutional quality of the alloy means that it is malleable and does not chip or crack. When hit with the golf ball in a certain way or hard enough, the brass putters would dent. If a golfer hits the ground with their brass putter, it could permanently deform and wouldn't be functional anymore. The next putter is carbon steel. These were used in the 1990s and early 2000s. Carbon steel is an interstitial alloy, meaning a lattice structure of large iron atoms with a small carbon atom intermixed in the smaller spaces. Carbon steel putters had one defect to them. They rusted very easily and very fast. Rust is a name for iron oxide, Fe2O3. When oxygen atoms come in contact with the carbon steel lattice, iron atoms are ripped away from the putter and it rusts and decays. This was the fault with carbon steel. The third putter material is stainless steel, the most common material today. Stainless steel is rust resistant due to its minimum of 10.5% chromium content. Like with the irons, this chromium reacts with the oxygen in the air and forms a protective layer that prevents the iron in the stainless steel from reacting with the oxygen and rusting. This chromium layer makes stainless steel rust and corrosion resistant. The crystalline structure of the stainless steel makes it harder than carbon steel and brass, which is why it is so often used in today's putters.
Hole in one!
What a putt! You made a birdie and learned about chemistry.
I haven't seen a game like this since my boys Henderson and Hasselback back in '09.
Thank you for listening to this episode of Chemistry Connections. For more student-ran podcasts and digital content, make sure that you visit www.hvspn.com.